In this video, we're going to go through another example where we need to calculate a confidence interval for population proportion. Okay, so let's go ahead and read the example. A researcher interested in the proportion of bass fish in the Chesapeake with dangerously high levels of mercury randomly sampled 567 fish and found that 15.3% of the sample had dangerously high levels of mercury. Find the 90% confidence interval for the proportion of bass fish in the Chesapeake with dangerously high levels of mercury. All right, so let's see here. Let's go ahead and first we're recognizing that we're doing a confidence interval. It says here confidence interval for population proportion. So let's go ahead and write down what the confidence interval is for population proportion. It's p hat minus e, margin of error, with p in the center, and then p hat plus the margin of error, okay? Where the margin of error is z alpha divided by 2, p hat, q hat divided by n. All right, great. So let's see what this question has given us. The researcher interested randomly sampled 567 fish. So that's their sample size, n. 567 fish. They found that 15.3% had dangerously high levels of mercury. Okay, so they already calculated the sample proportion for us. So 15.3% would be 0.153, right? Remember, when you're converting from percentage, so this is a percentage, to a decimal, just go ahead and divide that by 100. You'll get 0.153. All right, or another way to think about it is just move the decimal place over 2 places to the left. All right, so we're trying to find the 90% confidence interval. So that means when we're calculating this z alpha divided by 2, we need to calculate that critical value for the 90% confidence interval. So let's go ahead and do that next. Let's calculate z alpha divided by 2. Okay, so here we go. Let's draw this out. In the center, we have 90%, so 0.9. And so we have, here is the critical value, z alpha divided by 2. This is over here is the negative version of the critical value, so it's the same number, it's just negative. Okay, and all right, so when we go to our table, we need to find, well, what's this total area behind z alpha divided by 2? So I need to find what's this area in this tail over here. Okay, so in both tails, I'll have 0.1, right? Because 1 minus 0.9 is 0.1. So I basically have 10% left over in the tails. And so I've split that 10% in half, right? So I need to take 0.1 and divide it by 2. So that's 0.05, 5% in each tail. So 0.05, 0.05. Okay, so the total area that's behind this z alpha divided by 2 is 0.9 plus 0.05, which is 0.95. All right, so let's go to our table and let's look for where the area behind a particular z value is 0.95. Let's look for what is that value. What is that z value? Okay, so we're looking in our table, 0.95. So we see it here, 0.95 is exactly between 0.9495 and 0.9505. Okay, so I'll choose the z value that's exactly between these two z values. So that's exactly between 1.64 and 1.65. So that's 1.645. All right, so 1.645. All right, so there we go. There's my critical value. Also, in this calculation for E, we need to know what Q hat is. So let's go ahead and calculate Q hat. So Q hat is 1 minus whatever P hat is. So we can pull out our calculator. We can do 1 minus 0.153, 0.847, so 0.847. Okay, so now we have everything we need to calculate E. So let's go ahead and calculate E, the margin of error. Okay. So Z, which is 1.645, times the square root of P hat 0.153, Q hat 0.847. 7 divided by n, which is 567. Okay, so when we're calculating this, first calculate what's inside the square root. So 0.153 times 0.847, okay? Take that and divide it by the sample size, 567. All right, take the square root of that, and then multiply it by 1.645. Okay, so notice when I was calculating E, I never rounded any. I just in any intermediate step, I just plugged it all into your calculator, which is the way you should do it, because rounding mistakes in the margin of error can really mess up your confidence interval. All right, so I should round this to at least 4 decimal places. So 0.0249 looks like, because that 8 is going to round up because of the 6 that's after it. So 0.0249. Okay. All right. All right, great. So once we have the margin of error, we're ready to calculate our confidence interval. All right. So that's going to be p hat minus the margin of error. So p hat is 0.153 minus the margin of error, which is 0.0249. All right. Put the population proportion in the middle, and then 0.153 plus the margin of error, 0.0249. All right. Pull out your calculator. Do both these calculations. So 0.153 minus 0.0249. Okay, 0.1281. 1281. All right, and then 0.153 plus 0.0249, 0.1779. All right, so we are 90% confident, because this is a 90% confidence interval. So we are 90% confident that the proportion of bass fish in the Chesapeake Bay with dangerous mercury levels is between 0.1281 and 0.1779, right? So somewhere between 12.81% and 17.79% of the fish in the Chesapeake have dangerously high mercury levels.